Today we're going to learn how to write an exponential function when we're only given 2 points. Our first step is to actually identify the points. Here's point 1, x and y. Here's point 2, x and y. Now we're going to set up generic equations in the form of y equals a times b to the x. We don't know a and b, but we do know x and y. So using the point 0, 14, we're going to set up an equation, putting 14 in the y spot and 0 in the x spot. And then using the point 4, 8,750, we're going to set up another equation. Again, 8,750 goes in the y spot and 4 goes in the x spot. Now we're going to divide our 2 equations. Make sure to put the equation with the bigger exponent on top. That'll make your math easier. Divided by 14 equals a times b to the 0 power. Now 8,750 divided by 14 is 625. A divided by a equals 1, so that cancels out. And when we're dividing terms of the same base, we subtract the exponents. So we're left with b to the 4th. Now I need to know what is b to the 1st. So I'm going to raise both sides to the 1/4 power, because power raised to a power means you multiply the exponents. 4 times 1/4 is 1. But I have to make sure I do that to both sides. So then I get my final answer, which is 5. Awesome, that is my multiplier. And we're lucky in this problem that it gave us our initial value because it told us our output when time is 0. So I can very easily write my equation as y equals my initial value times 5 to the x power. Label our x and our y and write an equation. Label our x and our y, write an equation. Once again, making sure that the y is written as the output and your x value is written as your exponent. Now we're going to divide our equations. Make sure the largest exponent is on top. That'll make the rest of your math easier. (3,584) divided by 7 is 512. A divided by a is just 1, so that disappears. And we have 2 terms of the same base, which means we're going to subtract our exponents and see we have b to the 9th. Great, now I need to raise both sides to the 1/9th power. I'm taking the 9th root. So I see that my multiplier is 2. Once again, this problem gave us our initial value. So we can write our equation as y equals our initial value times our multiplier an unknown number of times. Example 3 is a little more complicated. The ordered pairs are not as obvious. Let's take a look. A sample of a radioactive isotope had an initial mass of 440 milligrams in the year 1990. I'm going to pause right there and write down that in the year 1990, they had a mass of 440 milligrams. And it decays exponentially, so now I know what kind of equation I'm going to write, an exponential one. A measurement in the year 1998 found that the sample's mass had decayed to 40 milligrams. So now I'm going to write the other piece of information, which is 1998. It was 40 milligrams. So we need to write our ordered pairs. We are not going to write them as 1990, 440. Instead, we understand that 1990 was our initial year, our beginning year, so we're going to represent 1990 with a 0. And we'll say that X is the number of years since 1990. So we'll represent 1998 as 8, 40, because 1998 is 8 years since 1990. Now our process is exactly the same as before. We're going to write our equations. Here's my X, here's my Y. Here's my X, here's my Y. Let's say we accidentally set up our equations where the smaller exponent is on top. That's okay. I'm going to show you how we can still get the correct answer. So once again, we're still going to divide. .440 divided by 40 is 11. A divided by A is 1, so that just goes away. We're dividing two terms of the same base, so we're going to subtract our exponents, and see we end up with b to the -8th power. That's a little more complicated than our previous problems, but we can still get the right answer. We just need to raise both sides to the correct rational exponent. Remember, we need our result to be b to the 1st. So I'm going to raise both sides to the -1/8 power, because a power raised to a power means you multiply the exponents, and -8 times -1/8 is 1. Make sure we raise both sides to the -1/8 power, and we see that our multiplier was 0.741. But we're not done with just the multiplier. The multiplier is important, but we need to write our whole equation. Thankfully, they did give us the initial mass. So we can very easily write our equation as y equals my initial mass times the multiplier some unknown number of times.